Okay, here's a section 3.1 lecture, molecular and formula masses. So we're going to talk in this very short section how to solve a particular type of problem. And it's essentially based on the idea that each element, each atom, I should say, of each element has a mass. And those masses are cataloged in the periodic table. And we call them the atomic masses of the elements. Okay, the atomic masses of the elements. So when you look in the periodic table, of course you want to be looking in the periodic table to review these values. They are given typically below the symbol for the element. So this is hydrogen, and let's remind ourselves, this number up here is the atomic, not the atomic mass, but the atomic number. Remember, this is the number of protons in one atom of hydrogen. Right, so one atom of hydrogen has one proton in its nucleus. Okay? This is the symbol for the element. And then this below here, this is what we're talking about in this section, is the atomic mass. Now remember, this is an average. It's an average of all the isotopes. Okay, average of all the isotopes. So hydrogen, for example, is primarily protium, which has an atomic mass of almost 1, and then there's a small percentage of deuterium, which has an atomic mass near 2. So the average of that comes out to 1.01. It's a weighted average, right? Okay, so let's take, for example, another element. I'm going to pick oxygen. Element number 8 is oxygen. Its atomic mass is 16. So again, that's the atomic mass. That's what we're talking about here. So really what we're claiming then is that on average, one hydrogen atom weighs 1.01. Now what are the units? 1.01 what? So atomic mass units are the units we're going to discuss. And it's typically abbreviated AMU. Now this is not technically precise. If we really wanted to look in very great detail at this, the units would be a little bit different than this. But for our purposes, for any general chemistry course, this usually suffices. Atomic mass units, which are AMU. Now, how big is one AMU? For example, you know essentially what a pound is, and you maybe know what a kilogram is, maybe you know what a ton is. What's an AMU? One atomic mass unit, one AMU, is very, very small. By definition, it's 1.661 times 10 to the minus 24 grams, G for grams. A typical pencil weighs about 2 grams, okay? So that's a really small mass, right? Sometimes it's in kilograms, so 1 AMU would also be 1.661 times 10 to the minus 27 kilograms, okay? So those are the quantities that we're talking about. So now what we want to do is we want to calculate something called the molecular mass. And the molecular mass is done for molecules, for molecular substances. So for example, O2, 2 oxygen atoms, that's oxygen, molecular oxygen, right? Or the example we're going to look at here is water. Water's a compound, right? 2 different elements, hydrogen and oxygen, so we would call that a compound. We're going to calculate the molecular mass. How do you calculate the molecular mass of a molecular substance? Very simple. You just add up the atomic masses of each atom in the molecule. So let's use water as an example. First, you ask yourself, how many hydrogen atoms are in one molecule of water? The 2, the subscript 2, tells you there's 2 hydrogen atoms. You then go to the periodic table and you look up the atomic mass of each atom. Well, 2 hydrogen atoms, so 2 times 1.01. I'm going to put the units in here, AMU. And then you say, how many oxygen atoms are there? Remember, with chemical formulas, if there's no subscript, that means it's a 1. So there's 1 oxygen. Where did I get the 16.00? Right here, right? That's the atomic mass of 1 oxygen atom. Add those together, you get 18.02. And that would be called the molecular mass of water. It's essentially how much one water molecule weighs. Now, a little bit about terminology. Today, when we're talking about molecular substances, again, oxygen, water, those are molecular substances. We use the term molecular mass. Okay, molecular mass is the term we use for that. There is an older term, but it's still out there and you'll see it in the literature. It's called molecular weight. Okay? So if you see that term molecular weight, it means the same thing as molecular mass. It's just an older term that's used. Okay? Now, if we have an ionic substance, then we use a different term. We call it the formula weight, or formula mass, sorry. I was using the old term, formula mass. The older term, I'll put it in parentheses, is formula weight. Okay? Formula mass. It's really just an issue of what type of compound it is. But you calculate it the same way as molecular mass. You just add up the atomic masses. So remember, ionic substances tend to be a metal with a nonmetal. So for example, sodium is a metal. Its atomic mass is 22.99 AMU. And let's take chlorine, for example. Okay. Suppose we have a compound, NaCl. We wouldn't ask what's its molecular mass because it's an ionic compound. It has a metal with a nonmetal. That's an ionic compound. So we would ask what's its formula mass. Okay, again, you might see formula weight as an older term. Same idea. There's 1 sodium, so 1 times 22.99 AMU. The units are the same. There's 1 chlorine, so 1 times 35.45 AMU. So that's going to give you 58.44 AMU. So that would be the formula mass of sodium chloride. We wouldn't call it the molecular mass because it's an ionic compound, but it is essentially the same idea. Try practice problems and checkpoints for these.